Hello friends, my name is BKK Kolhapure. This video will see the last part of work or energy, that is law of conservation of energy. We know that law of conservation of energy states that energy can neither be created nor destroyed, though it can be transferred from one form into any other forms in which the energy can exist, or in broad sense we can say the total mechanical energy is a constant. So this is a law of conservation of energy. Using this law we will try to simplify some of the problems or solve some of the problems. So energy can neither be created nor it can be destroyed. That is the principle of law of conservation. So let us see a problem here. A bullet of mass 10 grams is fired into a body of mass 1 kg, which is suspended by a string 1 meter long. So this is the body which is hanging, its weight is 1 kg, and this is the bullet, and the mass of the bullet is 10 grams. So this bullet is fired into the body, due to which the body will get swing here. So let's continue with the problem. A body of mass 10 gram is fired into a body of mass 1 kg, which is suspended by a string 1 meter long. The bullet gets embedded into the body, and due to the impact the body swings through an angle of 20 degrees. Find the velocity of the bullet. So you are required to find out the velocity with which the bullet is fired into the mass, so that the body will swing by an angle of 20 degrees here. So here OA is the length of the string, which is 1 meter, and that is nothing but OB here. So this is the angle theta which it is making. Now here we are using the principle. So energy can neither be created nor it can be destroyed. Whatever is energy before, it will remain same after the work, after the completion of the process. Now here, now if you see to this figure, when the bullet will hit the body gets swing, and it will be vertically rising by a height of h here. So here this height, if I calculate h, this h if I call, it will be equal to OA minus OC. Now OA here is 1 meter minus OC, this is a right angle triangle, so this becomes adjacent side. So adjacent side will be equal to minus 1 cos of 20, and if you simplify this you get 0.06. So once you find out this height, then we will find out the energies that are developed by the body. Let mass of bullet m, so this is 10 grams, mass of body, if I call it as capital M, this is 1 kg. So let us keep the same unit here, 1 kg. So this will be 0.01 kg. Velocity of bullet before impact. Velocity of the bullet before impact, if I take it as u, velocity of body before impact, so if I call it a small v, this will be equal to 0 because the body B is stationary. Now here momentum of the block and body, so this will be equal to before impact. So this, you know, momentum is mass into velocity, m into u plus m into the v, small v what we have taken. So this will be equal to mass of the bullet is 0.01, initial velocity is u, and this will be equal to 1 into the initial velocity is 0, so this will be equal to 0.01 u. So this is the moment of the block before impact, if I call this as kg meter per second. So let us call this as 1. Let v, capital V, be the common velocity of bullet and block or the body. Let V, when it gets tight, Both will be moving with a common velocity. Let V be that common velocity what we are using. Bullet gets embedded and both of them will move commonly here. So moment of bullet and body, momentum of bullet and body after impact, both will move after the impact. So this we know, m plus m into v is the common velocity, the capital V what we are taken into account. So this if I substitute 0.01 plus 1 into common velocity is v, so this will be 1.01 v. So this is the momentum before impact, this is the momentum after impact. Equating 1 and 2, you get 0.01 u is equal to 1.01 v. Let us call this relation 3. Now let us apply the law of conservation of energy. Applying law of conservation of energy. So which says that potential energy of bullet and body at V is equal to kinetic energy of the body and bullet after impact. So here the potential of the bullet and body at V when it gets right by an height h is equal to kinetic energy of the body and bullet after impact. Let's see, potential energy of body and bullet after impact is equal to, so this will be equal to m plus m into g into h. This is the potential energy of body and bullet at B. This will be equal to kinetic energy which will be equal to half into m plus m into common velocity is v square. Substituting the values here, 0.01 plus 1 into 9.81 into h value, the height what we have calculated is 0.06. 0.06 must be equal to half of 1 plus 0.01 into v square. So in this you get the velocity, common velocity with which both the body and bullet will be moving. This velocity will be equal to 1.133 meter per second. 1.133 meter per second. Suppose if you call this as 4. Now we know the common velocity with which it is moving. You got a relation here, initial velocity and the common velocity. You know the common velocity here. If I substitute this value, you get the velocity of the bullet when it will be striking to the body. So substituting 4 in 3, so you get u is equal to 1.01 divided by 0.01 into v is 1.33 meters per second. So you get the value of velocity as 114.13 meter per second. So this is the velocity of the bullet when it will be striking to the body. Now here this problem I can ask in another way. If I give the inertial velocity, for example we have calculated it is 114.13. A bullet is moving with the velocity of this, it is strike to the body and the body gets swung by an angle of, instead of giving the angle I will give you theta. So here in this case you will have to find out the angle theta by which it will be swinging. So here initial velocity will be known to you. So the very beginning where you have begun is h is equal to 1 minus 1 Instead of 20, it will remain as cos theta. Then when you substitute this value here, h, theta will be unknown there. You know the velocity, you will be knowing the initial velocity which it will be moving. If you substitute, you get the rotation theta, you get cos theta, solve for cos theta, you will get the value of theta. So either velocity will be asked to you giving the swing, or velocity will be given and the swing will be asked to you. So this is a variety of problem that you come across in law of conservation of energy, in which the bullet is hitting to a body with certain velocity. Let's see another example on law of conservation of energy. Now here this is the problem. A block A of 400 grams kgs is raised to another block B of mass 200 kg through a pulley system as shown in figure. So this is a figure, this is a pulley, a string is passing around here, two blocks are connected, one is A and another is B. This A is at a height of 10 meters and this B is at a height of 12 meters. So this is one. Now the problem is as shown in figure. Determine the velocity of block B when the block A is at the height of 6 meters above ground level. So this block A is moving down, so the height it will be attaining is 6 meters. At this position, you are required to find out what is the velocity of the block B. Consider pulley system of negligible weight and friction. So there is no friction between the pulleys. So let us take this problem. So here you are seeing two positions. The first position is the initial position of A and B. Then when it moves, you have got a second position of this A and second position of this block B. So let us draw that figure clearly here. This is a pulley. So two blocks are hung here. One is A, another is B. A, B. Now here this is a ground level. This is a ground level. Now here this height of the block A is 10 meters and this height of the block is 12 meters. These are the position 1 and 1 initially. Then this moves down and it will attain a height of 6 meters. Means this is moving down by a distance of 4 meters. If this moves down by 4 meters, so this will be rising up by 4 meters. So the position of this block now will be 12 plus 4 will be 16 meters. So this is the second position. This is the second position. So whatever is the energy at the first position, same energy will be there at the second position according to the law of conservation of energy. If you simplify this problem, you get potential weight of block A. So this is equal to the weight of the block given to you is 400 kgs. Let's convert it in Newton into, it is having a height of 400 grams and weight of block B, this is given to you in the problem as 200 kgs. 200 kgs, 400 kgs. So block A is of 400 kg and block B is of 200 kg. Definitely this will be moving down and that will be moving up the plane. We will find out potential energy of block A. Potential energy of the block A. This will be equal to, this is we are finding out position 1. So we know it is given by W mgh. So here the mass is given to as 400 kgs, convert it in mg, and the height is here 10 meters. So if you simplify, you get this value is equal to 39200 kg. We have converted into Newton meter. So this will be Newton meter. Likewise, potential energy of block B is equal to mgh. Say, so here this is related to A, this is related to B. So this mass of B is W into 9.81 into height of the block B here. Initial height is 12. If you simplify this, this will be equal to 23520 Newton meter. 23520 Newton meter. Potential energy of block A and B, this will be equal to kinetic energy. Potential energy is there because it is at a certain height. Kinetic energy of the body A and B at the first position is 0. So total energy of system at position 1. Position 1 will be equal to 39200 plus 23520. Potential kinetic energy is 0. So if you add this, you get the total energy is 62720 Newton meter. So this is the energy at the position 1. We'll see at the position 2. Then potential energy of the block A is mgh. mg. Now the second position of the block B is here 6 meters. If you simplify this, you get the value of 23520. Okay, 23520, and potential energy of the block B, this will be MBWH. The only change here will be height. So the final height at position 2 is 16. If you multiply it by 16, you get the value as 31360 Newton meter. Now the body is moving. Earlier position, kinetic energy of block A and B was 0. Now they are moving down, so there will be kinetic energy. So this is the total energy what we have got. I am just writing here. We will have to equate it. So that is the portion 1. So kinetic energy of block A is equal to half MAV square. So this will be equal to half into 400 into V square. So this will be equal to 200 V square. Likewise, kinetic energy of block B is equal to half mb v square. Both will be moving with the same velocity, so velocity remains the same there. So half into 200 into b, so this will be equal to 100 v square. Now at this position, the body will be having potential energy of A plus potential energy of B plus kinetic energy of A plus kinetic energy of B. Let us find out the total energy of the system will be equal to 2523520 plus 31600 31360 plus 200 v square plus 100 v square. So here we have got two total energies, so energy remains the same. So let us equate 2 to 1. if I equate 2 to 1, so we get this value will be equal to 54880 plus 300 V square. If I add this must be equal to 62700. If I equate it to 62100, we get the value of velocity V square will be 7840 divided by 300. So V will be equal to 5.1 meter per second. So V is here equal to 5.1 meter per second. Now this is the velocity with which the B will be moving in the upward direction. Same will be the velocity of B of A at the other direction, because the pulley is frictionless. So these are the varieties of problem that you see on law of conservation of energy. Please subscribe the channel for more videos. Press the bell icon for notifications. Comment section, you can ask any questions there. Thank you very much.